My name is Luigi Garavaglia. I'm the R&D manager of this group, ILIP, that is part of a bigger group called ILPA. And today we will present this system that deals with the monitoring of the ripening process of tropical fruit through the RFID sensor. This project is a collaboration among 3 different companies. ILIP, that I represent here, is a company that produces trays, pallets, and packaging for fruit, vegetable, and fresh food. And Radiosense, that is a company, an innovative startup of the University of Roma Tor Vergata, that has developed the system, the hardware, the software, the algorithm. And the third partner is Westphalia Fruit, that is the international supply of fruit, tropical or not, to the international market. So these 3 companies have collaborated to develop this system. With this presentation, we will explore the development of the Internet of Things, the IoT, and the opportunity for the adoption of the rain RFID sensor to check the avocado, but in general, the tropical fruit ripening. As you know, the avocado ripening process generates mechanical, colorimetric, biochemical, organoleptic modification of the fruit during this time. And all these modifications are collected by some sensor because all these modifications affect the electromagnetic property of the fruit. How do we collect this modification? We use a tag, an RFID tag, that is nothing more than a small antenna, miniaturized, with a microchip where we can write information, and a local querying system or reader which energize the tag, because the tag is passive, has no energy, no battery, and all this energy are reflected back to the same antenna and collected, and then detect, once it has detected the modification of the electromagnetic properties of the fruit, all this information are fed to an algorithm, and that correlated the firmness, so the the pressure of the fruit to the electromagnetic properties. So we have 3 classifications: firm, so hard, unripe, breaking when start to ripen the fruit, between 11 and 3 kilograms of pressure, and ripe where is below 3 kilograms of pressure to crush the flesh. This is the whole system. We have sensor, the signal processing, the remote data analysis, and the decision making of the operator. The sensors are, as I said, the RFID tag, miniaturized, and we will see that where they are placed, and this detect the changes of fruit ripening. Then there is the signal processing. It's electronic, that collect the data, send the data to a platform where we do the remote data analysis with the appropriate algorithm that link the radio frequencies modification to the shore, to the texture, and the pressure of the fruit. And all this information is sent back to the plant, to the operator, to the ripener, and allow the ripener to make the decision about what to do with the fruit that is in the ripening cells. So they can cool, they can keep them, they can increase the temperature, increase the time of exposition to the ethylene, or just, as I said, send directly to the packing and shipment. So this is in detail how it looks like this tag transponder. It's a small device, the antenna and the microchip. There are 3 of these tags placed on a flexible plastic material that will hold the avocado, and these 3 different tags are placed on the equatorial part of the fruit and basal part. So we have 3 points in which the ripening process is different. So we have an average of the ripening process. So the antenna microchip, and all this is placed on the support, and the support is placed on a cavity inside a plate. On this arrangement, just below this support, there are the antenna, the reader, and all the electronics that collect all the information and send the information to the platform for evaluation. It's very difficult to understand how this ripening will affect the radio frequencies, but normally is the dry matter that change, the solids, the humidity, the cluster of water that are different, and all this biochemical, physiological modification impact on the radio frequency and on different parameters, because there are more than 20 different parameters, radio frequency parameters that usually are collected and elaborated to generate the status of ripening of the fruit. So this is the process. We have the electromagnetic measurement. The data analysis is done in a report with an algorithm on the cloud, and then after that we have a classification of the fruit in terms of unripe, breaking, or fully ripe, based on the different pressure that we have assigned to each category, to each class. So above 12 kilogram is unripe, it's very hard. 11 start to become soft, and then 3.2 is ripe. And from 3.2 we can arrive until 1 kilogram that is ready to eat avocado. Apart having done all the work at the laboratory level, university level, on our laboratory, we have at the end, when we have collected all the information about the relationship between pressure and radio frequency measurement, we have moved this trolley to a packing house. In that case, is the packing house in UK of Westphalia fruit. And since more than 1 year, we are collecting information, we are elaborating and improving the algorithm with the real measurement done by the operator on the trolley. So we have collected a lot of data about the relationship between the radio frequency and pressure and texture of the fruit. Normally, to check the fruit quality, the operator use a durometer or a penetrometer or an electronic FTA measurement, but basically they remove the skin and they measure the pressure to break the pulp on the flesh of the fruit. Of course, this is invasive, and all the fruit are sacrificed and discharged. This is the prototype, how it looks like. This trolley has 4 shelves divided in 8 sectors for measure 8 different pallets in the ripening room. Inside this cavity on the bottom, we have the 3 RFID tags, and below on the other part of the shelf we have the electronic. So it's very compact. Is on wheels because normally when the product has reached the right ripening and the pallet start to be moved by the operator in another cell, this system will be moved and will follow the ripening, for example, in another room where there is another temperature, lower. So it's a trolley for that reason, because we move from one cell to another cell to follow the pellets that are ripened. And then, of course, all the electronics that are needed to collect and send the information through the cloud to our system and algorithm. This trolley has even temperature, humidity, pressure measurement, so we can correlate the temperature at which the fruit is kept and have the correlation between the variation of the ripening process with the temperature. This is the system, smartphone or computer that display all the information about the system. On the smartphone, we have the start and stop of the campaign. We have all the information about the past campaign, and we can see the ripening in different way, by sector, all together in just one average for 128 fruits, or just for each pallet during the time. Every hour, the system elaborate the data and send the data to the ripening operator. So basically, the operator place all the pallets inside the ripening room. Then they place the fruit on the trolley, selecting from 8 different pallets. The trolley is connected to the Wi-Fi, and the dashboard can be filled with all the information about variety, batch number, temperature, time of starting this process of ripening. When they start, this system is the moment in which they close the door and introduce the ethylene and increase the temperature 18, 20 degrees. And from that moment, the door is not anymore opened, because usually when you open the door, they lose the atmosphere, they lose the ethylene, the efficiency of the process is very low. But sometimes they do in this way to check by pressure every pallet for the pressure. So in this way, we can keep closed this chamber for at least a couple of days until we see that the quantity, this is the percentage of the fruit that are unripe, start after, let's say, a couple of days to become breaking or they start to ripen. When 50% of the fruit arrive at the breaking stage, there is an alert that is sent directly to the operator of the plant, and the operator of the plant can see that some pallets or the whole pallets that are represented by the fruit have changed the status from unripe to breaking. So that is the moment in which they have to check the fruit and decide what to do. If move to another cells or just continue the process, waiting the next stage. And that depends from the type of requirement of the customer. There are customers that would like to have product in the breaking stage to have more shelf life. There are normally other retailers that want to have product at the ripening just to eat, ready to use. So they push this ripening process depending from the retailer and from the requirement of the retailer. Let's see. Here is we show that every hour we have a reading at this point that corresponds, I don't know, you can see more or less at the 48 hours. There is the starting, a certain number of fruit start to ripen, and they become more and more soft, and another part start to become ripe. So there is a mix of stage depending on the position of the pallet, the variety, and the caliper that is inside this shell. And the alert will be sent between 14 and 64 hours normally, in which all the product arrive at 50% of breaking in this range. Of course, at that point we have the operator that decide what to do based on a real measurement of the texture. We did many comparisons between the electromagnetic reading and the texture reading to be sure that the system corresponds to the reading of the FTA measurements, and we saw that at a certain time the two systems are aligned. So the RFID system really give the same answer that the instrument, the FTA, give to the operator. We collect really a lot of data because we did one campaign every week for 1 year. So it's now the data are reliable and I would say standardized. So this system will provide data 24 hours a day, even during the night, when maybe the head of the ripener is not there, but he will receive the alert, so he could inform the people on the plant that something has changed, that they should check the product inside the chamber. Then increase the efficiency of the ripening room because there is no more breakage of the process, no interruption, no evaluation during the first 2 days of the fruit, and that means a lot of fruit that are saved from the measurements. We can extend to other tropical fruit. We did at experimental level the evaluation of mango, and we got the same result, but we are not yet in an industrial phase of evaluation, just at academic level. We reduce the fruit waste. This is extremely important because the number of fruit that are used for the FTA, it's really very high. Normally there are 6 for each pallet once a day, and normally in one cell there are between 30 and 60 pallets. So in 2 days you save a lot of fruit. And of course this could be a system for forecasting the shelf life of the fruit after the ripening process. So we are looking at keeping the fruit on the trolley and see what will be the shelf life, the evolution of this fruit at different condition of temperature. And then assist in continuous improvement and optimization of the ripening process of avocado and in generally of tropical fruit. So no more fancy tips to check the avocado, if avocado is ripening, you can see maybe at retail level that there are people that look at the pressure, they look at the flavor, or they just, like in that case, with some stick, they try to see if it's hard or soft. And that means that the fruit are damaged on the retail level, because all this mechanical and touching is really breaking and damaging the fruit. Above all, the fruit is at the ripe stage, ready to eat. Of course, this system could be even used at retail level. We are not yet ready to present this system, but the system works the same way. You can imagine a shelf in which there are the avocado on the same system, but with some LED light that correlate the electromagnetic reading to the texture and with the color. So you just have to take the color that you want. Green if it's ready, red if you would like to eat in a couple of days, yellow if it's in another ripening stage. So this will be the future, to move this system from the supply chain directly to the retail level. So thank you for being here and for your attention. If you have questions, of course, I'm here.